So in this video, I'll be looking at nodal analysis, and the best way to look at nodal analysis is using an example. So let's get going. Use nodal analysis to set up two equations for the following circuit in terms of V1 and V2. So we're given the circuit, and it has some current sources, and we're given V1 and V2. So just a side note before I do the nodal analysis, if I have a resistor between 2 points, and this voltage here is V1 and this one is V2, then we can also define a current through this resistor like that, and then we can say, okay, well, this I is equal to V over R, and this V over this resistor is V2 or V1 minus V2 over R. So all I'm doing is I'm subbing in V1 minus V2 for V, because V is the voltage over this resistor. So just a small side note before I do nodal analysis on this circuit. Okay, my raising sucks so much. Okay, now that I've fixed it. Okay, so use nodal analysis to set up an equation. Okay, so the first thing we can do is we can define some currents. So let's have a look here. We can define this as a current I1. We can define this as I2. And this is not given in the problem. I'm just doing this to help us solve the problem. This we can call, well, that is negative I2, but I'm just going to call it I4, I5. And out of this node, we've got that way, I6, and that way, which is negative of I3. That almost looked like a 2, but we'll just do it just for the sake of completion. Okay, so now we can of course apply KCL. We can add the currents up from this node. So we can say I1 plus I2 plus I3 is equal to 0 from KCL. Okay, I1 is the current down here, and we know the voltage there is V1. So using Ohm's law, I equals V over R, we can say, okay, V1 minus, this is ground, so minus 0. Whoa! Sorry, my lid just flew away. So I equals V over R. So then we can say, okay, V1 from there minus 0 voltage there over the resistance, which is 15. That's all for I1. Then for I2, we can say, well, the current out there is 15 amperes and it flows in the same direction as we defined I2. So you can say plus 15. And then for I3, we can say, okay, well, this is the current flowing this way. So we can say this voltage minus this voltage is going to give us the voltage over this resistor, like we saw earlier. So V1 minus V2 is going to give us the voltage over that resistor, and we say V over R is the current I3 through that resistor. So it's V, which is V1 minus V2, over the resistance, which is 20 in this case. And we all know that that is equal to 0 from KCL. And now we can just simplify this. So we can say V1 over 15 from there plus V1 over 20 from there minus V2 over 20 from there is equal to minus 15. You can simplify it further, so you can group the V1, so you can say 1 over 15 plus 1 over 20 minus V2 1 over 20 is equal to minus 15, and then you can of course multiply the minus this way, which would give you that. Okay, now we're going to do nodal analysis at V2. So now we say I4 let's just separate this. I4 plus our I5, I'm just doing KCL again, plus I6 plus I7 is equal to 0. Now that looks very complicated, but we're given quite a bit of the current, so it's going to simplify things. So I4 is this way. We know that I4 flows this way, and the 15 ampere source flows in the opposite direction, so it's minus 15 amperes. Then we over here have a 10 ampere source that way, which is in the opposite direction as I5, which makes it minus 10 amperes. Then this 30 ampere source flows in the same direction as I6, so it's plus 30. And then I7 is V2 minus V1, the voltage over the resistor, because remember I equals V over R. So then this voltage is V2 minus V1 over the 20, and then divide by the resistance, which is 20, and that gives you I7. Just to take note that that's the opposite of I3, so you can actually add a negative in front of I3 over here, and you'll see it's V2 minus V1 over 20, which is exactly the same. So plus V2 minus V1 over 20, let's take that away, equals 0. Okay, and now you can also simplify this. Minus 15 minus 10 plus 30 is 5. So plus V2 over 20 minus V1 over 20 equals 0. And then of course you can take that 5 over, and you're going to get V2 over 20 minus V1 over 20. And then of course you can multiply up by the 20 and times 1 minus 1 on both sides, in which case you will get V1 minus V2 equals 100.